So we're going to start with the graph, and we're going to do limits from a graph. And because you guys have been studying, and you, especially graphs, you should be super amazing at by now, I'm just going to let you tell me the answers to the graph. So the first question is it big enough for you guys to see? Okay, so then we are looking at the limit as x approaches 1 from the left. So we're looking for 1 from the left. What is that going to be?
4.
You got it. It's 4. So if I look at 1, if I'm on the left side of 1, so that's 1, and I'm on the left side, I find the graph, I'm going up to the graph, I get that value of 4. So 1 from the left here will be 4. Then we're looking for the limit as x approaches -2. So a thing I want to stress is important. A lot of times I see people, if there's like a 2 and a -2 next to each other, or a 5 and a -5, people get confused and they think that they're doing 5 the whole way through. So always pay attention to, like, is it a 2 or a -2? Pay attention to the fact that it's a negative, and then later it's a positive, because I've noticed people screw that up a lot. Okay, so the limit as x approaches -2. What am I going to have? You got it, David, -1. So remember, the limit is the expectation, not the reality. So my limit is the fact that it's that open dot there, it's -1. So then what's f of -2?
Does not exist.
Negative.
Oh, no. Yeah.
Yeah, it's going to be that -3 right there. So we do have a closed dot somewhere. We do have that reality, so it's -3. So f of -2 is equal to -3. All right, then the limit as x goes to -infinity.
2.
2, you got it. And what is the word for what we have happening right there?
Horizontal asymptote.
Perfect. We have a horizontal asymptote at 2.
I have a question.
Yeah.
If, let's say, a couple examples, like some examples, exams ago, you know, when I was doing it, sometimes are we gonna get penalized? Let's say if it's like let's say between 3 and 4, and it's like 3.5, but like we're not sure.
So you will not be penalized for that, but if there's a problem with that in the past, I'm actually quite surprised. Normally, if it is in the middle, it will like tell you. It will be like y is equal to 4.5.
Okay.
So like it should hopefully be very clear.
Okay.
Okay, so then the limit as x approaches 2, what do we have there? Limit as x approaches 2. So this is 2. What is the answer?
-infinity.
-infinity. On both sides, it's going down forever. So that makes it -infinity. You got it. So here we have -infinity. And then the limit as x approaches 1.
Does not exist.
It does not exist because the left side and the right side are different. We already did the left side. We said it was going up to 4. What's the right side going to?
1.
1, you got it. So 4 and 1 are not the same. So this is does not exist. And this is because limit as x goes to 1 from the left of f of x is equal to 4, which does not equal to the limit as x goes to 1 from the right of f of x, which was equal to 1. You do not have to write that, just to make sure that you guys understand why. Okay, so then the limit as x goes to infinity. What do we have? Infinity, you got it. So this is infinity. All right, so this next one was a question that I put on your mock test, but I actually didn't count it. It was like a bonus point that you could get on your mock test, but it is something that shows up sometimes. So let's see if you guys were able to figure it out. 3 from the left of 1 over f of x. Well, what is the limit as x approaches 3 from the left?
0.
Yeah.
0, you got it. We're going up to 0 there. So if I were to plug in, I would get 1 over 0. But what does 1 over 0 mean? What are the possible values it could be?
Infinity.
Is that the only thing? It could be infinity or negative infinity or does not exist. Good job. Can I get rid of the possibility of does not exist here? Yes. It is one-sided. And when we have a one-sided limit, we do not have does not exist as not an issue. So we really just need to figure out if it is positive or negative infinity. Well, let's go down here. I'm on the left side. I'm on the left side of 0. So how do we do this in real, how do we do this if we actually have a function? We plug in and we figure out if it's positive or negative. Is it positive or negative there? What I just circled in green. Positive, negative.
It's negative.
It's negative. So what I have here, it's like I have 1 is positive, 0 is negative. So which one do you think it is? Is it positive infinity or negative infinity?
Negative.
You got it. The value here is negative. So the answer is just negative infinity. Okay. So the x values where f of x is not continuous. We're also going to state why, the type of discontinuity, because it's surprising to me that this exam is not asking that. So what is our first discontinuity? The first place that we have to pick up our pin.
-2, x -2.
Yes, and what kind is that?
Removable.
Perfect. So x equals -2 is removable. Next. X equals 1, and what kind is x equals 1? Got it, a jump. And then someone else for the next one.
2 is going to be an infinite discontinuity.
You got it, x equals 2 is infinite. Then the next thing it says is the x values where f of x is not differentiable. So in this particular problem, it's not asking us to separate the continuous and differentiable and continuous and not differentiable from each other. So we're going to do that anyway. In other words, we're going to start off by saying, is a function differentiable when it's discontinuous? Good.
No.
No.
So the first thing that we're going to do is we're going to say discontinuities that we already listed. And that's going to be x is equal to -2, 1, and 2. The next thing we're going to do is look for the places where it is continuous, but not differentiable. Do I have any of those?
0 is, I forget what it is, but it's the one where it's like the horizontal tangent.
Okay, so I see what you're getting at, and I see someone I think said that in the chat as well. I'm just going to leave that in the air for a second. What's the, is there another place?
At
-1.
-1.
Yeah.
-4. So this is -4?
No,
-1. -1.
-1, okay, yeah. So at -1, what do we have going on there?
Cusp.
Yeah, you got it. Yeah, a cusp. So we keep cusps and corners together. Cusp, corner. And that happens at x is equal to -1. Then, so some of you are saying here. Now, I just
No,
want to
but that just means the slope is 0.
Yes, good job, Ellie. That just means the slope is 0. So here, the horizontal tangent line, the slope is 0. 0 exists. There is a slope, so it is differentiable here.
Could you say that at 1 there's a vertical tangent line?
You got it. So vertical tangent line is probably what you guys were thinking of. So let me write this.
Yeah, it is.
Yeah, okay. So slope is 0. There is a horizontal tangent line. and f prime of 0 is equal to 0. This is differentiable. But sometimes we have something called a vertical tangent line where it's not like this, but it's like this for a second. We don't have any of those here, but that is something that you should be on the lookout for. So I'm going to actually write it, vertical tangent lines, and there are none of them on this particular graph. Sometimes there are. So while we're talking about the graph, this particular exam also didn't have another type of question that often shows up with the graph, which is to evaluate the derivative at specific values. So, for example, I could have asked, or it could have been asked, to do f prime of 0 or the limit as h approaches 0 of f of 0 plus h minus f of x, or I'm sorry, minus f of 0 over h. This right here is the limit definition of the derivative, which hopefully you guys have memorized by now. You've all memorized it, right? Good. So when you see this, you'll recognize this is the limit definition of the derivative. So it's asking you the same thing. So these are the same question. And what's the answer? Hint, I already wrote it down. What is the derivative equal to at 0?
0.
0, you got it. So the answer to both of these is 0. So that's another question that you could be asked is what is the derivative at specific values? There's one I can't ask for this particular graph, but another thing that could happen is when else could you be asked for the derivative?
Is it continuous? No, is it differentiable but not continuous? And I think that's like always D&E.
Backwards. So when it's, well, actually the continuity part doesn't matter, just when it's not differentiable. So for example, I could have the limit as h approaches 0 of f of -1 plus h minus f of -1 over h. And what is that going to be? This is equivalent to f prime of what? What's the x value here? F prime of, you got it. This is -1. The x value here was 0, so this was equivalent to f prime of 0. Here it's -1. And what's the answer? What is the derivative at -1? Good job, David. The derivative at -1 is does not exist. So that's another type of question that could be asked. And the third would be when you have a straight line and you can actually find the derivative using 2 points. But we can't do that on this graph because there are no straight lines. Okay. While we are at the graph, are there any questions from like the practice or from anything that you guys have been doing to study about graphs or things that could come from graphs?
Pardon me, could you repeat that?
Do you guys have any questions from like the practice, any practice you've been doing about graphs? You could tell me no, for example.
No.
I just have one question. In an old exam, it was written same thing, you know, like you know, limits and everything. But it was like limit x approaches to 0, 5 f of x minus 6x plus 3. F of x, yeah, minus 6x plus 3.
Yeah, so we did questions like this in class. There are also a bunch of questions like this that are on the practice. All this is asking you to do. So this right here should probably have also told you what, oh, you mean from a graph?
Yeah.
Yeah, okay. So like when I plug in, this right here, I would just plug in and I would get this is 5 f of 0 minus 6 times 0 plus 3.
Okay, that's
So
what I
this
said.
is 5f of 0 plus 3. So then we're going to go up, and what does f of 0 equal?
In this case, 2, I think.
Is that 2?
Or no?
I'm going to go with,
1.
picking 0 wasn't maybe the best, but why don't we say 1.8?
Yeah.
Okay, yeah. So 1.8, so then this would just be 5 times 1.8 plus 3.
Okay, thank you very much.
Yeah. Hopefully, if they give you this question, though, it'll actually be at a value that you can know for certain without having to guess. Okay, so that said, next what we have is limits. We have continuity, we have a limit definition of the derivative, and we have derivatives. Is there anything in particular that you guys would prefer to skip to just to make sure that we get to the hard things? Or can we just go in order? Answers, guys.
Yeah, I think we should go in order.
Just so
Just
go on to limits.
Yeah, just cover all the bases.
Yeah.
Okay, all right then. Hopefully we'll have time to get to everything then. So A here. So I'm going to go off to the side to do these. We have 2x squared minus 9x. Actually, I'll just zoom out a little bit so I can. 2x squared minus 9x plus 7.
Will you post what like this after to us too, or?
I'll post the video.
Okay.
Yeah. So 2x squared minus 9x plus 7, and then 5x squared minus 7x plus 2. And then we were approaching 1. So what's the first thing that I should always do?
Plug in 1.
Plug in 1. Good job, guys. Plug in 1. And when I plug in 1, what do I get? Good
0 over 0.
Good job. So it's just 2 minus 9 plus 7, 0. 5 minus 7 plus 2, 0. So what's the factor I know I'm looking for?
X minus 1.
X minus 1. My goal is to cancel out that x minus 1. So then this is equal to the limit as x approaches 1. I'm going to have an x minus 1 up top. I'm going to have an x minus 1 on the bottom. Now, what's the other factor that has to occur since we know x minus 1 is there? I need to end up with 2x. So we'll have a 2x here. Oops. So I know I need 2x squared, so that means I have to multiply by 2x. On the bottom, I need 5x squared, so that means I have a 5x. Then what do I have to multiply negative 1 by to get positive 7? Negative 7. And what do I have to multiply negative 1 by to get positive 2? You got it, negative 2. So now I can cancel out those x minus 1s, and I can just plug in. So this is 2 minus 7 over 5 minus 2. And that gives me a negative 5/3 as my answer. Are there any questions about factoring?
No.
Okay. So limit as x goes to 10 from the right, x plus 5 over x plus 10. What happens here? When I plug in?
5 over 20, so 1/4.
You got it, 5 over 20. Wait, no, not 5 over 20, 15 over 20.
Yeah, my bad.
Yeah. So 3/4. And that's just the final answer. So this 10 from the right does not necessarily mean that it is infinite. It doesn't mean anything. In this case, I didn't have to do anything with the 10 from the right. It didn't mean it was infinite. It didn't mean that I plug in 10.1. I plugged in 10, I got a number. That number is my answer. The end. If I had had x minus 10 on the bottom, how would that have changed things?
Divided by 0.
You got it. So then I would have had division by 0. So I would have had 15 over 0, which we know is either infinity or negative infinity. In this case, does not exist. Oh, I forgot. I have to change that to a minus. Wait, why are we saying negative 5 over 0? Oh, okay. Okay, so does not exist is not there. We're looking at 10 from the right. So that's like 10.1. Now is when I would plug in 10.1. So I'm saying 10.1 gives me 10.1 plus 5 over 10.1 minus 10, which gives me a positive over a positive. So it's positive. So what's the final answer here?
Infinity. Positive.
Positive infinity. You got it. So a minus 10 on the bottom, we actually would have had to plug in 10.1 and do all of like the little chart thing to get the positive infinity. The plus 10 on the bottom, we plugged in, we got the answer. Okay, I plug in here, I also get 0 over 0. Always plug in. Just because there's that square root does not mean necessarily that you are going to get 0 over 0. So you should always check. How do I do this?
You want
Rationalize.
Yes. So how do I do that? What am I going to multiply by on the top and the bottom?
You're going to multiply both sides by square root of 10 plus 6x plus 2.
Perfect. Good job. And then we know how rationalization works. So I'm not just squaring each thing, though technically that's what ends up happening. So I have 10 plus 6x minus 4 over x squared minus 2x minus 3 times root 10 plus 6x plus 2. So don't forget to square that. These 2's get multiplied together to give a 4. What am I trying to cancel out here? You got it, x plus 1. So my goal is to cancel out x plus 1, which means that I'm going to have an x plus 1 in that factor right there. So I'll have the limit as x approaches negative 1 of 6x, 10 minus 4 is plus 6, x plus 1, I'm going to have some other factor, root 10 plus 6x plus 2. Now, to multiply x by x to get x squared, what do I have to multiply 1 by to get negative 3?
negative 3.
Negative 3. Now that one's really easy to factor just by looking at it in any case. Then I can factor out a 6 in the numerator. To get the x plus 1 there. Goodbye. Now I plug in. So I have 6 over negative 4. And then I have 10 minus 6, that's 4, so that's 2 plus 2. And my final answer here is negative 3 over 8. Are there any questions about that?
Sorry, could you go back? I just have to see the answer for a second.
Sorry. Are there any questions about rationalization in general? Any rationalization problems that you guys were doing in the practice that you have questions about?
Wait, I think I had a problem, but I just gotta find it.
Okay. Okay, in the meantime, I'm gonna write down the next question and then we can go back to Ellie's question if she finds it. So the next question is our next possibility for limits. Limit as x approaches 0, 9 over 3 minus x. Minus x plus 3. All over x squared. What happens when I plug in here? I get division by 0. Do I also get a 0 on the top?
Yeah.
I do. So I'm going to actually write it down. So I have 9 over 3 minus 0. That's 9 over 3 minus 0 plus 3. So that's actually 3 minus 3. So I do end up with 0 over 0. So this is one of those questions where we have a small fraction in the bigger fraction. So we have a complex fraction. What do I need to do here to deal with the complex fraction?
Multiply everything by 3 minus x.
Mm-hmm.
But by the way, for my thing,
Yeah.
it's with rationalization, but it's about like derivatives. So like, I don't know.
Okay, so we'll look at it when we get to derivatives then.
Okay.
Yeah. Okay, so I have 3 minus x over 3 minus x. Now remember, this 3 minus x on top gets distributed to both of those things. So I'm going to go back down to the bottom and do this just because I feel like this is one of the things that I've seen you still having trouble with. So I'm doing 9 over 3 minus x times 3 minus x minus x plus 3 times 3 minus x. So I just distributed that 3 minus x to both of those terms. The 3 minus x's cancel out. And here I have 9 minus, I'm going to just expand this thing. So I'm going to do first 3x, outer minus x squared, inner plus 9 minus 3x. Those 3 x's cancel out. And here I end up with 9 plus x squared minus 9. Okay, give it a second. Well, don't know what's happening. Oh, that worked. It never works. Amazing. Oh no, it didn't work. Never mind. Okay, so are there any questions about that expansion I just did? Well, OneNote does what it needs to do. Okay, so I have 9 plus x squared minus 9, and my result here is actually just x squared. Okay. Okay. Are there any questions about how I just did that like expansion there? So what that means is this is going to be the limit as x approaches 0 of x squared over x squared times 3 minus x.
Okay.
No, I don't think there's questions.
So then do we just like cancel it?
Yes, I'm sorry. My OneNote is having some issues here. I'm trying to like, it's frozen again. So then we just cancel the things. Okay. Oh my gosh, OneNote. Is it working again? Am I moving? Yeah, there we go. All right, got it. Okay, so then we just cancel the things and our final answer is?
1/3.
1/3. You got it. Okay, are there any questions about this? Okay, all right, next one then. Sorry, OneNote just died. So any questions about this type of thing? Because I did notice that this is one of the things that you guys were having a lot of trouble with.
Why is there a 3 minus x on the bottom?
Because I multiplied by 3 minus x over 3 minus x. So it had to, so that I could multiply by 1. I multiplied it in the numerator, and that's what I did right here. So this was multiplying 3 minus x through the numerator. But then it also had to get multiplied on the denominator so that I was just multiplying by 1.
Oh, okay, so then you just, okay, I see.
Yeah, so then it just stays there. I don't have to like distribute it through or anything. Okay, so you guys want me to do another one of this type of question? Because like I said, I've seen you guys having struggling with this a lot. We're good?
Yeah, I think it's fine.
Okay then, next. X minus 3, x minus 5. Two minus x squared. And we're going to negative infinity.
So is it the take the big stuff method?
Yes, so here we have this approaching infinity. So this is definitely the take the big stuff method. So I'm taking the big thing from each of my factors. And this one's actually really straightforward because it doesn't have any powers. I don't have like any squareds or cubes that I have to bring with me. So I'm just gonna have that this is equal to the limit as x approaches negative infinity of x times x times x over negative x squared. And when I simplify this, what do I have left?
Yeah, minus x.
You got it. So I just have a minus x left over. And that's really important in this case because what I'm plugging in is negative infinity. So when I plug in that negative infinity, I have negative infinity. What does that give me? You got it. So it turns out that in this case, it's a positive infinity as my final answer.
How'd you get negative x?
So I have x cubed on top here. So I have 3 x's on the top and I have 2 x's on the bottom. So then those 2 get taken away from the top. So this is like x cubed over negative x squared. So that negative is that negative. That didn't work out quite how I wanted.
Oh, so it just becomes x over -1.
Exactly, which is just negative x.
Okay, I see.
Yeah. Okay, so any questions about this? And do you guys want me to do another one that's a little more challenging that does involve like taking powers and stuff like that? Or are you feeling happy and good at this?
Yeah, I think we should do one with powers.
All right, we'll do another one then. I'm just gonna do the limit as x approaches infinity. We'll say 2x squared plus 4 cubed times 3 minus x cubed times 1 minus x squared to the 4th times 2x plus 1 squared. Yeah, okay. So here, this is the same problem, except that now I'm taking the big stuff from each factor, but I have to take those powers with me. So I'm taking each of the powers. So here I end up with the limit as x approaches infinity of 2x squared cubed times negative x cubed over negative x squared to the 4th times 2x squared. And the reason that it's important and that it's sometimes a little bit challenging to think about is because this 2 and these negatives are also being put to the power. So my first question is x to the power of a to the power of b. Am I adding a and b or multiplying them?
Multiplying.
I'm multiplying them. So this is like x to the a times b, which means that up here, 2 cubed is 8. So this is 8x to the 6. That negative stays because a negative 1 cubed is still negative. Down on the bottom, does the negative stay? I have an x to the 8, but is it going to be positive or negative?
It's gonna become positive.
It's going to become positive because we're putting it to the power of 4. So negative 1 to the 4th becomes positive. So that's x to the 8, and then 2 squared is 4, so that's 4x squared. And then x to the a times x to the b, am I adding those powers or multiplying them? What was that?
Yeah, you're adding.
I'm adding them, so that's x to the a plus b. So then this is the limit as x approaches infinity of negative 8x to the 9 over 4x to the 10. So that's the limit as x goes to negative infinity. Negative 8 divided by 4 is negative 2. And I have 1x left in the denominator. I had 9 on top, 10 on the bottom, so I only have 1 left over on the bottom. So what does this become?
0.
0, you got it. So this is like negative 2 over negative infinity. Division by infinity is always just 0.
I thought division by, wait, division by 0 is always infinity,
Yes,
and then division by infinity is always 0.
yes.
Okay.
Okay, any questions about these limits at infinity? So question,
No.
in the one from the actual test, that first question, does that function have a horizontal asymptote?
No.
No, because our answer was infinity. When we get infinity or negative infinity, there is no horizontal asymptote. What about in the second one? Is there a horizontal asymptote?
No. Yes. No.
What was my answer?
0.
Is 0 a number? Does 0 exist?
Yeah.
Yes. So the horizontal asymptote is at y equals 0. So here there wasn't one because infinity doesn't exist. Infinity is a concept, a thing that just means getting bigger and bigger and bigger. Whereas down here, we got an actual number, so there is a horizontal asymptote at y equals 0. Was it 3 from the left, or the right, or neither? 3 from the left. As usual, the first thing we should do is plug in, and when I plug in, what do I get? I got a 0 on top and a 0 on the bottom. So how do I deal with absolute values?
You take the closest, like the biggest, like how do you say, 8 plus,
Okay.
and then you put it in the formula. If it doesn't do anything, as in like if it doesn't change the sign, we keep it like that. But if it changes the sign, like it turns the final answer into a negative, then we put the, how do you say, those two lines there, I forgot how you call them.
The absolute value.
Yeah, the absolute value, you times the answer by -1.
Perfect. So 3 from the left, what value are we going to plug in to see that? A good value on the left side of 3.
2.9.
2.9, you got it. So I'm like 2.9 minus 3. Is that positive or negative?
That's negative.
Good. So then the absolute value of x minus 3 on this interval will be -1 times x minus 3. And then how am I going to factor the denominator? I have a greatest common factor of x, so I'm going to factor that out, and look, I have an x minus 3 left over. And my answer here is, when I'm doing my final answer, do I still plug in 2.9 or should I plug in 3?
3.
3, right? So like plugging in 2.9 is useful for two things. One is absolute values, the other is finding a sign to see if it's infinity or negative infinity. Both of those times we're just finding a sign. So this is just -1/3. And that's my final answer.
Sorry if there's like weird sounds. There's workers at my house, so like.
It's okay. I don't hear them.
Okay. Good.
Hopefully no one else does. Okay, any questions about the absolute value problem?
We need to show how we got the -1, or we could just like plug in.
You should show it just to be safe. Like, show me that you know, that you're not just guessing. Okay, so then the last limit we have here, didn't we already do that? Okay, limit as x goes to 1, 2x squared minus 8x plus 14.
Is the test just one page?
Wait, your midterm?
Well, this one.
No, it's, so that line is actually two separate, oh wait.
Oh, okay.
No, it's
There's
just,
like 4 pages. Oh my god, we're not gonna have time to finish.
but this is a final.
Oh, okay.
Right, like, so like, for example, starting at question 7, you can't do any of them anymore.
Oh, okay.
Yeah, like, so
And in our test tomorrow, there's no trigonometry,
there's
right?
no trig, exactly.
Okay.
I feel like this particular final has a lot of limits on it. I don't feel like they normally have this many limits.
But for the test tomorrow,
Yes.
because in the practice test you sent us, it's like mostly derivatives.
Right, because you're
So-
supposed to combine it with the mock test practice.
Oh, okay. Because like for the mock test, like the practice test was like basically like very similar to the exam. So like the practice thing you sent us will be similar because then the whole exam is going to be like derivatives.
No. So like your
Okay.
exam, I just didn't repost practice problems when you
Okay.
had the practice for the mock test. So your test is, you had that list of topics on the first page
Yeah.
of the practice. It's not just derivatives. It's like
Okay.
all of that stuff. So you should also be using the mock test practice.
Perfect. Okay, thank you. And is it good if we just do like those exams here?
I mean, they do cover, I tried to make them cover like everything. So
Mhm.
hopefully, but you should also like look in your notes and try to see if there's anything missing, do extra problems for things that you struggle with.
Okay.
Okay, so first thing we want to do is plug in 2 minus 8 plus 14 over 5 minus 7 minus 2. I do not get any zeros. So this is 16 minus 8 over... And the answer is -2. I don't know why there were 2 questions on this final that involved just plugging in. That is very weird. I have never seen that before. Clearly, I don't know what's happening.
But if we plug in, can we just put the answer we found without putting like doing what you just did?
Yeah, absolutely. I just
Yeah, okay.
I just don't have my calculator with me.
Okay.
So So I was trying to like. Continuity. You guys ready?
Yep.
Okay then. So number 3. So there are like a billion limits and then an easy continuity question. Interesting. So remember that for continuity, it is a 2-step thing. First, we look for values that are not in the domain, and then we look at the breakpoint. And in this case, my breakpoint, there's only one of them, it's just 1. So I'm gonna try to write down this problem. Okay, all right, we got it. What time do you need to be there tomorrow? So your exam tomorrow is at 4 o'clock. And you're told to try to get there 15 minutes early to line up. So 3:45. Also, don't forget your student IDs and don't forget your calculators. There will be a calculator check. So make sure you have your calculator. I'm pretty sure your student ID is in your phone. So you will need to have your phone with you, but I think I sent in the message, like you're gonna need to make sure that your phone is put under your desk. If it is found on your person during the exam, that is considered cheating, unfortunately. So try to make sure that you, and it'll be in the announcement, that your phone is under your desk. Also, don't wear your iWatch if you have one. You will be asked to put that under your desk as well, so you might as well just not wear it. Okay, so step 1 is to find those values that are not in the domain. So we're basically starting by looking at each of these functions, x plus 1 times x minus 4 over x minus 2 times x plus 1. And I'm setting the denominator equal to 0 because what I want to know is where does division by 0 happen, because those are places not in the domain. So x minus 2 times x plus 1 is equal to 0, which gives me 2 values, x equals 2 and x equals to -1. Are both of those values on the interval in question?
No.
Which value can I get rid of?
2.
2, you got it. That one's not on the interval. This one, however, is. So what we know is that f of -1 does not exist. So already this cannot be continuous. There is no reality. So then we take the limit to name the type. So the limit is x approaches -1 of this function. And can I cancel out those x plus 1s? I can. And so do I get an actual number? What does that number tell me? You got it. F of -1 does not exist. The limit is 5/3. So those two things are not equal, which means that x equals -1 is a removable discontinuity. And then the next thing is 3 over 2 minus x. So again, I'm setting the denominator equal to 0. So 2 minus x is equal to 0, which gives me x equals 2. Is that on the interval? Is that greater than or equal to 1? Yes. So what does f of 2 equal? So what is f of 2?
It's going to be 3 over 0.
So, which does not exist. So f of 2 itself does not exist. We get that 3 over 0. Then, if I do the limit, as x approaches 2, that 3 over 0 is actually going to become important because it tells me what? What does it tell me about the type of discontinuity? You got it. So f of 2 doesn't exist. This limit gave me that 3 over 0, which we know means infinity. So x equals 2 is an infinite discontinuity. And I'm done with step 1. I found the values that cause division by 0. I looked at the limits to identify the type of discontinuity. Which brings me to step 2. And that is to look at my only breakpoint, which is x is equal to 1. So I'm going to be doing the limit as x approaches 1 from the left of this function. Now, a lot of you guys messed this up on your group work and on your mock test, so I want to really point this out. The limit sign does not disappear yet. So I still have my limit sign, but now I replace f of x with the function. And I'm doing the top function because that's the one that gives me values that are smaller. So here I have x plus 1 times x minus 4 over x minus 2 times x plus 1. And now the limit sign can disappear because I'm going to plug in. I'm going to actually evaluate the limit. So I get 2 times negative 3 over negative 1 times 2. And the answer here is 3.
Wait, so why is at -1 instead of removable discontinuity?
So at -1, it's a removable discontinuity because the problem here, the thing that broke from the limit definition was that the limit exists. The left and right sides are equal. The limit exists. It equals to 5/3, but it doesn't equal to the reality. So if I were to graph this thing, it would be like saying at -1 and 5/3, my limit is going there, but the reality is there is no closed dot. There's just that open dot right there.
Okay.
Okay, so that's the limit from the left at 1. Now we're going to look at the limit from the right. So now we're at the bottom function. And that also equals to 3. So right now I have that these two things are equal. Is that enough to tell me that this is continuous?
No.
No. What else do I need to look at?
F of 1.
F of 1. And which function am I going to for f of 1?
Bottom one.
The bottom one.
Bottom one. What if there were no line?
Then it does not exist.
Then it does not exist. And in that case, so just imagine another problem where there was no line. The limit from the left equals to the limit from the right equals 3. F of 1 does not exist. What kind of discontinuity do we have there?
Removable.
Removable, you got it. But now do I have a discontinuity?
No.
No. So here we can say f of x is continuous at x is equal to 1. And we are now done with this continuity problem. Are there any questions about this continuity problem?
No.
Good. So I want to know if you guys have questions about continuity from the practice and stuff like that. But I want to do the other continuity question first because I just want to make sure that we really have time to talk about it because it's a little bit challenging. So 3 over x minus k. K over 1 minus x. Okay, so here we're doing the same thing as in the last question. We're going to think of this as a two-step problem. And in most of these questions, step one is kind of just like not important. But in this particular one, it actually is. So we're going to start off with our step one, and we're going to look at division by 0. So in other words, I'm going to start with 3 over x minus k. So I'm setting x minus k equal to 0, which gives me x is equal to k. So here this is important. There is a discontinuity if x equals k is on the interval. The interval is x less than 2. So there is a discontinuity if k is less than 2. And that's important because we're going to have to come back and think about that at the end. So there's a discontinuity if k is less than 2. Then we'll do 3 over 1 minus x. 1 minus x is equal to 0, gives me x equals 1. Is 1 greater than or equal to 2?
No.
No, so this is not on interval. We don't care about it. So now we're on to step 2. And this is important as well because again, on your mock tests, a lot of you just we're like, oh, I don't need to use any notation or limits. We're doing limits here. Like we need to be showing our answer with the limit definition of continuity. So I need to see your limits that you're actually doing. So I'm doing the limit as x approaches 2 from the left of g of x. Is 2 from the left the top function or the bottom function? Which one? Top. You got it, top function. And 2 from the right is the bottom function. So I want to point out, when I'm grading, this is one of the things that gets graded. Are you associating 2 from the left with the correct function? So if you're not doing limits, then I can't see that, and you're not going to get points for that. So like, all of the steps that we're showing here are important. So this is limit as x goes to 2 from the left of 3 over x minus k. Now that 2, am I plugging it into x or k? X, you got it. So this is 3 over 2 minus k. And now I want this to equal, so I'm setting them equal to each other, the limit as x goes to 2 from the right, which is the bottom function. So that's k over 1 minus 2, which is just negative k. Which one of these is also equal to g of 2? The left side or the right side? The negative k, you got it. So this is also equal to g of 2. I don't have to do g of 2 separately in this case because it's just already equal to one of these. So now I can actually do the setting them equal. 3 over 2 minus k is equal to negative k. I'm going to multiply both sides by 2 minus k. So I will get 3 is equal to negative 2k plus k squared So I moved everything to the left side and subtracted 3. So I'm like subtracting 3, and then I just flipped the equation. How does this factor? What are my factors here?
K plus 3 and K minus 1.
Flip that, but yeah. So k minus 3 and k plus 1. It has to be minus 3 because the middle is negative.
Okay, yeah.
Yeah, good. So this gives me two values. K is equal to 3 and k is equal to negative 1. Am I done with this problem?
No.
No, because remember, if k is less than 2, we have a discontinuity from step 1. Do
We
I
look at k minus 1.
You got it. Of these cause a discontinuity. Remember, so step 1, in step 1, discontinuity. If k is less than 2, negative 1 is less than 2, so k equals negative 1 causes a discontinuity. So this is continuous everywhere, or continuous, I don't remember how the question was asked, so we'll just say on R, if k equals 3. We cannot put k equals negative 1 as an answer because it causes a discontinuity. And in the solutions that I give, a lot of times for these problems, you'll see me actually plug in those k values to see the function it gives, because a lot of times in the past, that's really helped people to visualize what's going on here. Do I need to do that here? Let's say 1 and x equals negative 2. Okay, so I think that, David, me plugging in will actually answer your question. So if I plug in k is equal to negative 1 to this problem, then what I'm going to end up with is 3 over x plus 1 and negative 1 over 1 minus x. And then up top, we have x less than 2. And on the bottom, we have x greater than or equal to 2, right? And so x does matter. Right now, if I have this thing right here, and we were to do step 1, I would be like x plus 1 is equal to 0, which gives me x is equal to negative 1. And that is on the interval. Does that answer your question, David? Yeah, so the x value matters, but only in the sense that the x value is an interval of x values, right? If I plug in 3, if I go and I plug in 3 here, then we're not gonna have the same problem because I will have 3 over x minus 3 and 3 over 1 minus x. And now, again, the intervals are the same. So x is less than 3, x is less than 2, x is greater than or equal to 2. And here, when I plug in, I would have x minus 3 equals 0, x equals 3, but that's not less than 2. That's not on the interval. So again, you guys don't have to show me this plugging in stuff if you've done your step 1 correctly, but this kind of shows why the 3 is going to be continuous everywhere, but that negative 1 actually causes that discontinuity. And this is something that you guys did with Ethan. I don't actually remember, no, I didn't watch your video, so I don't know how he talked about it exactly, but I assume it was somewhat similar to this. Okay, any continuity questions from the test or something that you guys want me to do? Or from the practice test, or questions about continuity? Good. Oh, Okay, so I also want to point out that neither of these continuity questions said state the limit definition of continuity. A lot of times they do. So these both said, well, the first one said by using the definition of continuity. We just did that. That's like using the limits. A lot of times you're also specifically asked to state the limit definition of continuity. So you should definitely be able to do that. Do you guys want me to write it down for you? So I'll just write it up here.
In an exam, is it okay if we say it in our own words with the actual?
It depends on how the question's asked, because a lot of times it specifically says state the limit definition of continuity. And that is a very specific definition that you'll need to give exactly as is, like as the limit definition.
Okay, so we can't write like when the left limit equals the right limit. We need to put in like left.
Yeah, you could actually show me your limits.
Okay.
Yeah, like just show me in math that the left limit equals to the right limit, equals to the function, and they all exist. Okay, are there any other continuity questions? Okay, hang on, I'm just gonna mute you guys. There we go. Okay. Are there any questions about continuity? You guys are all gonna kill continuity tomorrow, right? Yes. Okay, state the limit definition of the derivative. I'm just gonna do this because I've already done it numerous times today. Limit as h approaches 0, f of x plus h minus f of x over h. Now, I would like to point out that in the limit definition of the derivative, there is the word limit. That should tell you that in your definition, there should be a limit. If you forget the limit, then you do not get any points for this. So some of you did that on the mock test. Every semester, I have numerous people that just give me this. I am happy that you remember that, but that's not the definition of the derivative. It is the limit as h approaches 0 of this thing. So please don't forget your limit. And now we are going to use this definition to find the derivative of the square root of 5 minus 3x. So that means we're going to actually, yeah, that's fine. So that means we're going to start off by doing f of x plus h. We need to know what that is. Is that correct, what I wrote?
Yeah.
Are you sure?
No.
What can I do to fix this?
Does the h not go in the square root?
The h is in the square root. You got it, Kiana. Brackets. Good job, David. So
Okay.
I need brackets around x plus h. Remember, your x plus h should always be in parentheses. And that's important because what that makes this is 5 minus 3x minus 3h. That 3 right there is getting distributed to both of the things inside. So just make sure to remember to always put your x plus h in parentheses. And now we can put this into our limit definition. And to do this, we know that we are trying to factor out a factor of h, so we want to cancel out a factor of h. We also don't have to plug in for these because we know we're going to get 0 over 0, so we can just immediately rationalize. So when I rationalize, I'm going to get 5 minus 3x minus 3h. minus 5 minus 3x over h times. And did I screw anything up?
You have minus 3x when it's supposed to be minus 3h.
So that's the first thing. So we have minus 3x minus 3x. I need an h there. And also brackets. That minus 3x should be a plus 3x. Because that minus is getting distributed to everything inside the square root. So we could also have done this in 2 steps and just said minus 5 minus 3x and put the 5 minus 3x in parentheses. So then I can cancel out the 3x's and I can cancel out the 5's and I only have minus 3h left. So if you only had minus 3x left, then you would know you have a problem because you wouldn't have an h to cancel out. You should have an h to cancel out. And I cancel out my h's, goodbye, goodbye. And I get negative 3 over, now I'm plugging in the square root of 5 minus 3x minus 0 plus the square root of 5 minus 3x. How do I add 2 square roots together? Does that just get rid of the square root? No. Square root of x plus square root of x is just 2 square root of x. So this is negative 3 over 2, the square root of 5 minus 3x, and that's my final answer here. Okay, so the limit definition of the derivative, here we had to rationalize. Note that there are 3 main limit techniques that we learned could show up in the limit definition. So rationalization, clearing denominators, or just factoring and canceling. Any of those 3 things could show up depending on the function for which you're trying to take the derivative. Are there any questions about the limit definition of the derivative? Ooh. Okay, are you guys ready to do some derivatives then? Yes, okay. Wow, this is amazing. We're actually like getting through all of the stuff that's on your midterm tomorrow. Okay, so each of these derivatives, I'm just gonna get rid of the ones that we can't do yet. So I'm not gonna be able to do D, and I'm not gonna be able to do F. Those are not questions that we've learned how to do yet. And then for the trig ones, I am going to replace the trig functions with other things because there will be no trig on your midterm tomorrow. So like there are some trig functions here. I'm gonna do the exact same thing. I'll just replace the trig functions with other functions. So we have 2x to the e Okay, so when I see a derivative, what's usually the first thing I should do?
Simplify, like write them down in a simpler form.
You got it. So I'm gonna have 2x to the e. Should I do a quotient rule on 4 over the square root of x?
No, just put x minus 2.
You got it. Or minus 1/2. Exactly. So I'm going to bring this up and say this is plus 4x to the minus 1/2, and then plus x, what power is this going to be to?
Minus 1/2. Oh, what? Oh, okay.
You were still back at the other one. It's okay. It's okay. Okay, so x to the 5/3. Good. Now, each of these is just a simple power rule. I'm going to bring the e down and subtract 1. I'm going to bring the negative 1/2 down and subtract 1. And I'm going to bring the 5/3 down and subtract 1. This is x to the e, not e to the x. So there is a difference between x to the e and e, between x to the e and e to the x. This one needs a power rule. This one needs an exponent rule. So I will have then 2ex to the e minus 1 minus 4 over 2, so that's a minus 2, x to the negative 3 over 2, then plus 5/3, x to the 2/3. And that's my final answer here. Now, hang on, I want to look at something real quick. Okay, so just because on your group work, I was really, really surprised at how many people did the quotient rule for this part. I'm gonna do a question from our group work, 4x plus 27 over the square root of x plus 2. Should I do a quotient rule here at 27 over the square root of x plus 2?
No.
This is the same thing as like 4 over the square root of x. Doing a quotient rule there is going to make this super hard to simplify. If you don't have to simplify, it's not a big deal. On the group work, you did have to simplify. So a quotient rule is just going to make your life more challenging. This is exactly the same problem. It's just there's an x plus 2 under the square root. So the first thing I would do here would be to just bring that up. 27 x plus 2 to the negative 1/2. And then I don't have a quotient rule to do. And it's just pretty like a straightforward derivative. So my y prime here would be equal to 4 minus 27 over 2, x plus 2 to the negative 3 over 2, times the derivative of x plus 2, which is just 1, which is a lot more straightforward than doing a quotient rule. So in this case, it's not the same thing as this. With this one, there's an x on top. I'm going to have to do a quotient rule or a product rule. With the numerator just being a constant, that is a sign that you should just simplify. Does that make sense? That said, I'm not going to finish this question from the group work, but you have the solutions to the group work, and there's the link to the video I made where I talk through the solutions. This last question went really, really, really terribly. I recommend, if you don't watch the video of the group work solutions, at least watching the video of this part. So like the end of the video where I talk through this specific question. It really didn't go well. So I hope that you'll take the time to do that. Okay. Next derivative. Log base 4 of 8x cubed minus 6x
Is it better to study the mock test or the group work? Or like, should we do both?
You should, I mean, I would recommend doing both. Like that said, the mock test is, like I made them both, right? And I'm also making your midterm. So they're both quite useful, but like if there are questions, so yes, you should definitely make sure that you're very comfortable with the group work. If you noticed the mock test, like a lot of questions were similar to group work questions. So you should definitely make sure that you're comfortable with the group work, but you should not like reject to do the mock test as well. Like it's going to be equally important.
Okay, thank you.
4x squared minus 3x plus 1. And then the last thing that we have here is e to the x tangent of 3x to the 4th. Okay. So remember when we have a sum, we want to look at each part separately and ask ourselves, product rule, quotient rule, chain rule, or none. So for the first part, product rule, quotient rule, chain rule, or none? Yes, chain rule. So there's going to be a chain rule, and this is log base A of G. What about the second one? Also a chain rule. So this is A to the G. And what about the last one? That's going to be a product rule. You got it. That's going to be a product rule because I have two things being multiplied together. So we're going to go through and do our derivative, and we're going to apply each of these chain rules. So log base 4, I put the 8x cubed minus 6x on the bottom with a ln 4, and then the derivative goes on top. I'm going to do this in 2 steps, but you can absolutely do it in 1 step. That's fine. Then I'm going to apply my rule here, 6 to the 4x squared minus 3x plus 1 times ln 6 times 4x squared minus 3x plus 1 prime. And now my product rule happens. The derivative of the first times the second plus the first times the derivative of the second. And now I'm just going to highlight the things that, the derivatives that I have left to take. Do any of these derivatives I have left to take require a product rule, quotient rule, or chain rule? Which one? 1, 2,
Yes,
or 3?
the derivative of 3x4 plus.
You got it. That's going to be a chain rule. So inside of this product rule, I had a chain rule. So this is going to be y prime is equal to 24x squared minus 6 over 8x cubed minus 6x times ln 4, 6 to the 4x squared minus 3x plus 1 times ln 6 times 8x minus 3 plus the derivative of e to the x is e to the x, so that doesn't change. And then I'm just going to do this chain rule all in one go. I bring the 2 down, 3x to the 4th plus 1, I subtract 1, and then I pull out the derivative, so I have 12x cubed on the outside. And this would be my final answer. So notice I really separated this into 3 different derivatives, and I thought of each of them separately. The first one plus, the second one plus, the third one. And I had different thoughts for all 3 of those things. Ellie, do you want to ask your question now?
I mean, I don't know if it's like, it's like use the definition of the derivative to compute f prime x given f of x equals 7 plus square root of 2x minus 1. But like we can finish the other questions instead, it's fine.
I mean, this is going to be really similar to what I just did in any
Yeah,
case.
exactly.
Right here. Yeah.
It's okay.
Okay. Okay, then. Next derivative is secant cubed of cosine of 1 minus x. All right, what are we going to do here? So instead of secant, we will have...
Sorry, can you just show the answer again?
Yeah, sorry.
Just the end. Okay, yeah, it's fine.
All right, there we go. So e to the 1 minus x to the power of 4 plus x squared plus 5, all cubed. That's my g. I'm going to do this in one go, guys, but I'm going to slowly pull out each thing. So like a fruit roll up, I'm just like pulling out one thing after the next when I'm doing into my chain rules. So this is going to be some embedded chain rules. So here I'm going to have y prime. First, I bring the 3 down. And I subtract 1, and then I pull out the derivative of what's inside. So now I'm doing the derivative of my g. So I'm looking at that inside function. And I'm like, okay, well, for e to the 1 minus x to the 4th, look, I have another g. So I'm going to deal with that. So I'll have e to the 1 minus x to the 4th, but now I'm pulling out the derivative of 1 minus x to the 4th, which has a new g, which is that inside that 1 minus x. So this is going to be 4 times 1 minus x cubed times the derivative of 1 minus x, which is negative 1, plus 2x, and the derivative of 5 is 0. Do you guys want me to break that down into multiple steps? Or did you follow? You're so good at this? Awesome, I love it. I'm hoping that's not sarcasm. Okay, do you guys need me to break this down into multiple steps? You can tell me yes or no,
I
please.
think it's fine.
Say again, Ellie?
I think it's okay.
Awesome, good. Yes, you can put the negative 1 with the 4, but you would then need to put that in parentheses, just so like you would have negative 4. You would have like negative 4 times 1 minus x cubed, and that's totally fine. Just make sure it's in parentheses so it's not being subtracted. All right, next.
Where did the negative 1 and the 2x come from?
So the 2x, that was my derivative of x squared. And the negative 1 was the derivative of 1 minus x that I pulled out. So,
okay, I see.
So it's like e to the g times g prime. And that g prime is 1 minus x to the 4th prime. So that was another chain rule.
So yeah, so you do like the e to the 1 minus x to the 4. And then it's like the derivative of that. But then you need to do, so then you need to do like put the 4 at the front. And
you got it.
Okay, I see.
Okay, next. So hopefully you guys have been practicing enough that this is like, I told you in the beginning that hopefully you'll eventually get to the point where you can do like multiple chain rules in one go, but it comes from practice. So hopefully you're starting to get there. All right, one more derivative, and that is, so we'll do e to the 3x plus 1 instead. Actually, I'll do 2 to the 3x plus 1. Okay, what rule do I need here?
Quotient.
You got it. That's my F. That's my G. Again, if you want to just write down the answer, you're welcome to it, but I'm going to actually do this one in 2 steps. So I'm doing the derivative of the top times the bottom minus the top times the derivative of the bottom. All divided by the bottom squared. Now I have 2 derivatives here. In those 2 derivatives, do I have any chain rules, product rules, or quotient rules? Chain, you got it. I have a chain rule right here. Perfect, good job. So that's my chain rule. So then y prime, y prime is equal to 2 to the 3x plus 1 ln 2 times the derivative of 3x plus 1, which is 3, plus 12x squared, fourth minus 4x to the 8, minus 2 to the 3x plus 1, plus 4x cubed, and then this is just a simple power rule, 32x cubed minus 32x to the 7th, all over 8x to the 4th minus 4x to the 8 squared. And that's my final answer.
In the exam, is there going to be simplification?
Yes, and so that's like the last thing that could show up on your exam that we haven't seen yet, which is the possibility of simplifying or needing to simplify to find horizontal tangent lines. I think we have time to do one real quick if you guys want, and then we can be done for the day. So I just want to go back to this exam and point out that on this exam, these are actually all of the questions we could do. But question number 10 is just a different way of asking find a horizontal tangent line. So I could do that one, but I think it's a little bit different than the ones that we've seen so far. We'll probably see more questions like that when we get to question 10. So I can do any kind of simplification that you guys want. Do you guys have preferences? Do you want to do like a product rule, a quotient rule?
Like a chain rule, I guess, like a complicated one.
Yeah, definitely there will be chain rules involved.
Oh, okay.
Yeah, okay. So we'll go with Sandra said the quotient rule. So we'll do that. So find the horizontal tangent lines. So I'm going to do f of x. We'll just say this is x squared minus 9 over x squared plus 3 to the power of 4. And so this is going to for sure be a chain rule, but it's also got that quotient rule inside there. So this is like g to the power of 4 to start off. So then I am doing f prime of x. I bring the 4 down to the front. I don't touch what's inside. I subtract 1, and then I pull out the derivative of the inside, which is my quotient rule. So there's going to be a quotient rule for g prime. And I'm just going to do that quotient rule immediately because I don't want to keep you guys too much longer, but I do want to see the simplification. So it's the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. So what we have said about quotient rules like this is that to simplify, I need to start by treating the numerator here as if it's like I just did a product rule. I want to find the greatest common factor and factor that. So we're going to find the greatest common factor here. What is it?
$2x.
You got it. It's just 2x. My greatest common factor was just 2x. So now another thing I'm going to do when I'm simplifying this is we've said that x over y to the power of a, I can distribute that power. And I'm going to do that with this power of 3 that I have right here. So I'm going to have 4 times x squared minus 9 cubed all over x squared plus 3 cubed. So I distributed that power of 3 to the top and the bottom. And that's my first fraction that I have here. And then in the second one, I'm going to pull out that greatest common factor. And what I have left over is x squared plus 3 minus x squared plus 9. All over x squared plus 3 squared. Okay, are there any questions so far about the simplification that I have done? Okay, now same as when we're doing a product rule. First we pull out the greatest common factor, then with what's left over, we expand and combine like terms. So I'm going to do that here. Expand and combine like terms. And I'm doing that only inside these parentheses right here. For the rest, I'm going to remember that x to the a times x to the b is equal to x to the a plus b. And I'm going to multiply this 4 and this 2x together. So I'm combining things. It's all multiplication. Order of multiplication doesn't matter, so I can move that 2x to the front. And I get that this is 8x times x squared minus 9 cubed times inside my parentheses, x squared minus x squared, those cancel out, and I have a 12 here. And then I'll have x squared plus 3 cubed squared, so that gives me a power of 5 on the bottom. And then the last thing I can do is multiply that 12 times 8, so I'll have 96x times x squared minus 9 cubed all over x cubed plus 3 to the 5th. And this is my f prime of x. This is the simplified form. Are there any questions about that simplified form? About how we got there? Awesome.
Just
Great.
how did you get again the divided by x squared plus 3 to the cube?
I took this 3 right here, so I'm going to highlight it. I'm going to highlight it in blue for us. This 3 right here.
Yeah.
And I applied this rule over here, which tells me that.
Okay. Yeah. I see.
Okay. Okay, so now to finish the question, I need to set this equal to 0, which is equivalent to setting the numerator equal to 0. Remember, the denominator doesn't matter when we're setting equal to 0. So I'm setting equal to 0. So we're setting the numerator equal to 0. So I have 96x times x squared minus 9 cubed is equal to 0. 96x equals 0 gives me x equals 0. Remember, powers don't have to come with me. X squared minus 9 equals 0. So that's x squared is equal to 9. So x is equal to plus or minus 3. And I found 3 values where the tangent line is horizontal. And that's my final answer. And we actually managed, I think, to cover pretty much every single type of question that's going to happen on your midterm tomorrow, except the type of question. So finding horizontal tangent lines, but there were different types of simplification that could happen, or types of questions that you might have to, equations that you might have to solve that we didn't get to today. So for example, the last question on the group work is one that could happen, but we did not get to today. So go watch that video. And now we are done, and I will see you guys for the midterm in person tomorrow.